Good morning, good afternoon, good evening, depending upon your time zone. My name is Seth Early, and welcome to our webinar series. This is the fourth in a seven-part series. And today we have Sanjay Mehta, we have Patrick Hofel, and we have Trey Granger, who will be our guest presenters. My background is I've been in information management and knowledge management for 30 years. So I've been doing this for a very long time. I wrote a book. You can see my book up in the corner there. People may be familiar with that. It's called The AI-Powered Enterprise, and still valid. It was written before a lot of large language model popularity, but everything in there is still valid. It was written in 2020, but it's all about information architecture and knowledge architecture ontologies, and that's what we're going to be talking about today with regard to trustworthiness in retrieval. Patrick, why don't you give a quick thumbnail of your background?
Yeah, hi, Patrick Heppel, 30 years in technology and information architecture, information retrieval. I've been in consulting for the last probably 15 years, and I am confident that today's topic is going to be interesting to everyone who's listening.
Terrific. Sanjay?
Thanks everyone for joining. My name is Sanjay Mehta, and similar to Pat, I've been in the tech industry for decades as an engineer and an implementer and consultant, and a lot of it's been in e-commerce as SME for various large organizations and search. And so excited to be here and talk about specifically those types of applications with the large language models.
Excellent. Thank you. How about yourself, Trey?
Hi, everyone. I'm Trey Granger. I'm the founder of Search Kernel, which is a consultancy focused on AI-powered search from the engineering side. I'm also the lead author of the book AI-Powered Search, and my career has been almost entirely in search and information retrieval with a real focus on relevance, and sort of data science approaches. So here's my book. If you're interested, we sort of go end to end through everything it takes for software engineers, developers, data scientists to implement AI-powered search, sort of covering everything from retrieval augmented generation, which we'll talk about predominantly today, to other approaches like generative search, learning to rank, using user behavior, searches, clicks, and other signals to power search and relevance, and then sort of all the hot topics with semantic search using dense vectors, sparse vectors, knowledge graph learning, hybrid and multimodal search, all those things. So if you're interested in learning more from a technical standpoint, you can check the book out. And
I've ordered my copy. I'm looking forward to it. My book, AI Powered Enterprise, is more of a business book. So that's a lot of organizations have used that for business leaders. And it looks like Trey's more on the technical side, which is great. And so buy them both. We're recording today. I want to thank our media sponsors, CMS Wire and Vector, spelled VKTR. We're going to go about an hour in total today. We want your input. We want you to ask questions throughout. We have a couple of polls, and then we have a survey afterwards. So if you could be so kind as to fill that out, that would be great. Again, I mentioned early information science, who've been around for a long time, and we have a roster of clients from Fortune 1,000 companies down to mid-sized businesses. And this is all the work that we do. We work in knowledge management, information architecture, product data architecture, customer data, and content operations. It's all important stuff. And here we are in our series. So all of these are recorded. We are now kind of mid-series. Next week is going to, or in 2 weeks, we're going to talk about transforming business operations. Then we'll get into vendor strategies. We're going to have some friendly vendors on the call, and hopefully we'll get the real deal from them. And then how it's really impacting people's lives, both in terms of your day-to-day work and your career. There's a lot happening in this space. And also, Sanjay and I and Heather Eisenbron, who's one of our knowledge architects, are delivering a workshop, half-day workshop at KM World in Washington, D.C. Our session is on November 18th, and it is about building a knowledge and information architecture for generative AI. So the stuff we talk about here, we're going to be teaching there. And there's companion articles to the series that will be on Vector. And the first two are published. The third they have. And of course, we'll write the fourth after today. So you can follow along there as well. So our agenda today is really talking about why AI and generative AI struggle to keep up with the latest information. But that's less of an issue than it is about your corporate information, right? They're increasingly adding citations, they're increasingly adding real-time retrieval, but they still don't understand your information, and really thinking about how we can make sure that the generated content remains timely, and understanding how RAG works, Retrieval Augmented Generation, really, which is to me the keys to the kingdom. That is the most important thing that is going to happen to any organization in the near future. And a lot of analysts have also, predicted that. We have a quick poll. I want to understand if you are familiar with RAG. How familiar are you? Is it, what is RAG? I don't know. Is it that you're planning? Maybe you have some pilots that are happening at the department level. Perhaps you've deployed it. Maybe there's a customer-facing applications. Choose where you are in that journey. A couple of folks are not necessarily familiar with it, which is interesting. That's fine. That's what we're here for, to fill in that knowledge gap. And then none of the above. Let us know none of the above. What does that mean? If you're not deploying it, let's see, what is not on the radar? Maybe you understand what it is. I don't know if I missed an opportunity for another choice there, but tell me in the chat where you are in that. There's a Q&A tab, and you should be able to put stuff in there if you'd like. I'll let it go for another moment or two, but it's interesting that you're not really deploying this in customer facing. So that's interesting. So what's fascinating about this is there's so much discussion of this, of how it's replacing customer service agents, and yet we're not seeing that happen because people don't necessarily trust the results. So let's end the poll here. Your last minute, well, let me share it. Interesting that we don't see a lot of deployed applications or even planning, which is interesting. Okay, so let's keep going. So what is RAG? What is Retrieval Augmented Generation? And what I'm starting to see, or what we're starting to see, is that there's increasing awareness of this. The Wall Street Journal, in the print edition, not like the CIO Journal, which usually has a lot of technical stuff, but the print edition said companies are looking past chatbots, and it still can be a chatbot, but it's really saying that they're looking at this new way of thinking about this. Retrieve a company's data and use it to augment what generative AI is doing. And so we're trying to use this to not just generate the answer, but to be able to access our data. And what I wanted to do is, Trey, I know you've been at some conferences recently, and people have been talking about retrieval augmented generation. Tell me what your experience has been.
Yes, it's funny. I won't say where, but within the last few weeks, I was at a more of an academic conference, and one of those conferences where you have people with posters and boards, and they're talking about what they've been working on. And out of about maybe 15 or 20 posters, 5 of them were talking about RAG and about using their organization or their institution's data and doing research about how to use it with chatbots and those kinds of things. And so, being somewhat of an expert on search and information retrieval and RAG, I thought I'd just, kind of see what they were doing. And out of the 5 folks that I spoke to, 4 of them were using some tool out of the box, maybe like Llama Index or something like LangChain or something, and just sort of turning it on and putting their data in it and trying and seeing what happened and calling it RAG. But when you sort of ask them, well, what is it actually doing under the covers? How's it using your data? How's it, is it using a vector database? And they really didn't know, which to me indicated RAG is very much a buzzword and it's very powerful. But I think there's a massive lack of understanding, even for people who are spending time researching and trying to build things. I think there's a real lack of understanding about how it works and how to do it effectively.
Yeah, I find that true. Sanjay, Patrick, do you guys have any similar stories, or what's your understanding of people's understanding?
Yeah, Seth, I agree with Trey's assessment and with your assessment. There's a lot of buzz about it and people want to know, but the actual mechanics, it's a scary proposition, this AI taking over the world thing. And for all the talk about it, the actual level of penetration, and we saw this in our survey a minute ago, the actual level of penetration is not as deep as the news buzz would lead you to believe. And so we want to help make it a little bit more accessible to you in terms of what is this thing, why would I use it, and how do I get started?
Great. So what is generative AI? Right? Generative AI is something that creates new content. because it's learned the patterns of language. It learns about concepts and terminology and the real world. And those patterns are used, that becomes knowledge that's embedded in the model. When we say large language model, it has large numbers of parameters. Sanjay, Patrick, and Trey could get into all the details of what a large language model actually is under the cover, but there's lots of layers of a neural network. There's lots of parameters. There's relationships between terminology, but it forms this understanding of the world. When I say understanding, it's not really understanding. It understands how things are related and predicts an output. It's actually a statistical model. In other words, it'll take a prompt, which is the question people ask, and then it'll say information, what words would be most likely to occur after this. Now, I know when you use it, it's hard to think of it as in such simplistic terms because it's like mind-bogglingly powerful. But it's using that learned knowledge of the world by ingesting all of that other content. But it's not a copy of the training data. They've trained it on basically every source in the internet, violating copyright rules, and there's a lot of lawsuits around that. But what this means is that it doesn't necessarily know your organization. It doesn't know your terminology. It doesn't know your policies. It doesn't know your products. It can answer general questions, but if you get into a very specialized piece of information, and really your organization is competing on your knowledge, right? Because it's knowledge of customers, their needs, the marketplace, competitors, solutions, how you solve problems, your methodologies. That's all knowledge that your organization competes on and differentiates in the marketplace. That is not going to be available to a large language model in terms of training. I don't know why that pop-up happens. It's like a new version of Windows, and all of a sudden I'm getting things popping up all the time. Anyway, so you saw that, right? Did that come up? Because I'm sharing my screen. Should have just shared my presentation. So again, what we want to do is we want to say, how do we tell it about our world? And so when we think about this, so I just want to get your thoughts on this. Now, this is not as much of the problem around training cutoff, because that is being mitigated, or, a lot of times they're missing audit trails, but that's being mitigated. It's really the last bullet. And I wanted to get your thoughts, Sanjay, Patrick, Trey, just any of you can chime in about this idea of, it's non-public information, it's proprietary information, competitive IP.
So, Seth, a real simple example is an LLM can do an amazing job creating a lunch menu for a whole month and tell you what you could serve, but it can't tell you what is on your lunch menu this week inside the company. It just doesn't have that information. But generally, it could create a great lunch menu. It just can't tell you what yours is.
Mm-hmm. That's a great analogy. Sanjay?
Yeah, no, exactly. If you look at even your public, like Google result, right, that you see, we all know it's whatever it's been able to crawl or access, right, through its bots and what's publicly available. But whenever you're looking at something that's potentially internal, right, and that's again where like Google had like a search appliance, for example, that you would install internally to get access to that information. That's sort of part of the gap, right, we have is, offering that same capability, this protected information. So I think that's kind of like a big piece of what we're trying to do here with RAG, for example.
Mm-hmm.
Yeah, I agree. I was going to say, I'll talk about what the models have a little bit more, maybe when we talk about hallucination, but the large language models are really, really good at two things. One is being able to interpret what you're saying or what you're asking and what you're looking for, the intent side of things. And then being able to take data and kind of, I use the word reason loosely, but reason about it and come up with a response and a summary and explanation. There's a middle piece, though, which is having access to the data that's needed to be able to provide that analysis, to provide the summary. And so RAG really gets to that central part, which is being able to access the right data to power the response. And so I think, obviously, in the context of an organization, you have your own proprietary data. There's, security on it for who can access and who can't. And that wouldn't be available on the public web. So even if the LLMs had full access to all of human information where they could recall them, which they don't, even if they did, you would still need to pair the models with your organization's data.
Yeah, precisely. And again, this is the stuff that's behind the firewall. This is the stuff that's unique to your organization. even if you get a language model that is tuned to your industry, like pharmaceuticals or life sciences or legal, it still doesn't know your processes. It doesn't know your terminology. So, it's great at understanding what people are doing. Like we used to have to map utterances to intents when we were doing building chatbots, right? My computers, I locked me out. I forgot my password. My username doesn't work. All of those utterances, those variations resolved into an intent, which is change my password. Well, this does that on steroids. This is understanding what the user is asking. And then it's taking, once it gets that data, it's making it more conversational as a response. So it's really interpreting it, and then it's also interpreting the query or the prompt to the question, and then it's interpreting the result and making it more conversational. I look at this stuff at an information retrieval continuum, right? Everything, I've used this slide for many years, and I've changed a little bit about it. But the idea here is that, whether it's basic search or knowledge portal or virtual agent or RAG, they all need a knowledge base. They all have search integration. They all need some information architecture. Even basic search derives an information architecture, right? Even when there's none, even when there's no metadata or tags. And then the user experience has been changing, right? It's rather a search box and a list of documents versus things that become more conversational and more personalized. And of course, there's lots of other enabling technologies, but it's all on a continuum. These are all mechanisms for retrieving information. So there's no real mystery to this. I like to say it's complex, but it's not mysterious. Okay, so here's, we're not going to get a lot of responses on this because not a lot of people have deployed, but if you have deployed or if you have played with RAG, how confident are you in the results? Are you getting results that you need? Now, I just talked to a company the other day who was deploying RAG, and they were doing it with a company that was part of their owners' portfolio companies, and they weren't getting the results that they needed. And then I started asking questions about how they're curating the content and whether they're tagging the content, whether they're chunking the content, or whether they're looking at use cases. And the answer to a lot of that stuff was no, they were not. And there was no surprise to me that they weren't getting the results that they were needing, because we have to have good knowledge sources. The problem with retrieving your data from your organization is many times that data is not in very good shape. So we only have a few people answering, some saying they're neutral, some saying they're not confident. I don't get any very confident or confident. So I'll give you another moment or two to put in your vote if you'd like. But let me go ahead and end the poll here, because it looks like not a lot of folks are doing it. But so just a few people responded. But again, some have not deployed, some are not confident, and it looks like some are neutral. So anyway, okay, let's go ahead and carry on here. So the other thing that you'll hear about are specialized language models, right? You hear about generalized, the GPTs, and then you have specialized ones like from Bloomberg, IBO, there's LexisNexis, there's other language models that are specific to industries. But then you also need your corporate terminology, your company-specific terminology. So, there's specialized language models, and then there's that last layer. Because again, even if you have an industry-specific language model, it may not apply. A lot of times they're kind of cumbersome, and you do need that terminology in order to tag and organize content. So that's just something to think about, is that you still need to think about your corporate ontology, your corporate taxonomies, and those are very important. And here's where we talked about, we've already mentioned this. This is kind of the idea of, you can generate publicly available information. There's potential exposure of IP, potentially missing audit trails, but then you can process that response in a conversational format, or you can retrieve. And again, this is your proprietary information. You can do it in a way that you don't expose your IP. It's the corporate knowledge, it's auditable, and so on. And the same thing, you're using the LLM to process the query and present results. This is pretty straightforward. We kind of already talked about this, but did you guys have any other comments you wanted to, any color commentary? Okay.
Good.
So, and this is the problem with data. I'm not going to read all these bullets, but let's talk a little bit about this. When you think of data and content and knowledge, a lot of times it's not written in a way that is very specific to the needs of the user, right? Corporate marketing departments or support organizations will have tons of content like the tech docs, the inserts, but try to find the information that you need. It's very, very difficult. That's why people call tech support. The organizations need to point to their data, but it's not structured well enough. It is not of good quality. Many times there's a lot of redundant information, there's out of date information, there's ambiguous information. You can't tell one document from another because they're so close in nature. So we need to think about having some kind of structure to that information, some kind of curation to that knowledge. And again, you get very useless information, like don't use an electrical appliance in the shower, or stuff like that. You're seeing things that are not necessarily useful to you. And so what we need to do is we need to contextualize that information. We need to understand the user and their need and the use case. I know we're going to have another slide that talks about context, but any general commentary here about the quality of information?
I'll just say that in a RAG system, when the search engine or the data source, the vector database, what have you, is being queried to find information to give to the model, that's the R part of RAG, retrieval. It's really, really important to make sure that that process works well, does model the appropriate query to find the best ranked information and bring it back, because it's a garbage in, garbage out problem. Ask your model a question and it needs additional information, and say there's 1,000 documents and the right information is in 10 of them, but it gets the wrong 10, then what you get out of the model is going to be a very bad answer because the model doesn't have the right information. So I think most practitioners building RAG underestimate the challenge and the importance of the retrieval part of RAG. It's also the hardest part of RAG. That's probably why they underestimate it. But I think it's really, really important to focus both on the data source, but also how the data source is modeled so that you can retrieve, and making sure that your retrieval algorithms do find the best data.
Yep. And that's why use cases are so important. That's why understanding personas or roles are so important, understanding their journey so you can anticipate the information. We're doing a project right now for a field service organization. And what we're doing is we're looking at what these service techs have to do day to day in the field, and looking at those tasks and saying, well, what information are they actually retrieving here? And then we're tagging it, right? We're organizing it. We're building metadata models, because those become additional signals to enrich the data when you embed it in a vector model. I don't want to get into too much detail, technical detail, but the idea is metadata is important, right? Metadata is very important. And we did a study where we showed with metadata, we were able to increase the accuracy of retrieval by 30 percentage points, right? It was just blew it out of the water. And we're showing those examples as well. And when you think about it, we have all this content. Many times they're monolithic documents. They're 300-page documents. People who've been to my webinars may have seen this before, but we break that content up. We have to break it up anyway to ingest it into a vector space. The vector space is really a mathematical model of the content, and it uses different size windows in order to chunk the content. But if you chunk it in a way where they're question-answer pairs, or the components have pieces of metadata that identify what they're useful for, you're going to have a much better result, right? Because you can now search that content and you're being able to retrieve it in the right context for the process step that you're in, depending upon your level of expertise. Whether you're highly maybe you're a certified technician, maybe you're a brand new technician. You're going to need different information depending upon who you are. So that's kind of the idea, is that we're doing this in order to build those chunks to build bite-sized answers. And we have a couple of slides on this, and let me give this to you, Trey. This comes from your book and your research. You want to talk a little bit about this in the context of how we understand that user's need and that user's intent.
For sure. So this diagram I use obviously in the book and most of the talks that I give publicly to really try to underscore what it means to try to do retrieval and to try to search. And so at the end of the day, whether you're talking about a public search engine, a web search engine like Google, whether you're talking about an internal enterprise search engine, or whether you're talking about a vector database that's serving data up to a large language model, the goal is to understand the intent of the query or the question coming in, and to appropriately find the right data and then to return it based upon that intent. And so this slide is the dimensions of user intent. And I like to break it up into three general contexts. So there's this content understanding context where you've got the data that your enterprise has, or the data that's in your search engine, and understanding the words and phrases and what it means. There's the user context, which is who's requesting the information, what do you know about them, their profile, their behaviors, their culture, those kinds of things. And then there's domain understanding. And that is, for my business or for my organization, what are the terms and phrases and relationships and sort of like this is where you get into ontologies and knowledge graphs, where what are the things that matter in my domain. And so interestingly, if you think of just a system that purely focuses on the content understanding context, that's like a traditional keyword search engine. You type in words, phrases, maybe vectors, and you match data. If you look at user understanding alone, that's something like collaborative recommendations, where I'm looking at the user's behavior, what they've looked at, what they've clicked on, their behavior, and I'm building an understanding of the user, and I'm just recommending things to them based upon only what I know about them, not necessarily based upon the content itself. And then the last one, if you focus just on the domain understanding context, that's where you're building out ontologies and taxonomies and knowledge graphs, where it's disjoint from the content and disjoint from the users. It's just what's the meaning of things in my domain. But where this gets really interesting is when you start to look at the overlaps between these. So for example, if you look at the overlap between the content context and the user context, you'll see up there at the top, that's where you get to personalized search. So that's when you can do retrieval on the content you have, but you can cater it to the needs of the person that you're running the search for. Similarly, if you look at the intersection of the content context and the domain context, that's where you have semantic search. So this is marrying the data that I have with what I know about my domain, and I'm matching based upon those interrelationships. And of course, the end goal of all of this is I want to understand the user's intent by combining all these contexts together. So the real goal of a RAG system is to be able to understand the full context of the content, the full context of the user, and the full context of the domain. And if you can marry all of those together, then you really get at the heart of interpreting the user's query and analyzing the results that are coming back. And then for the retrieval part of this, you can optimize and make sure you get the right results back. So I think laying it out that way helps to really understand the goal.
Excellent, excellent. And we're going to be talking about this in a deeper way as well, because again, this is understanding who that user is and their digital body language. What are they doing? What are they clicking on? What types of interactions have they had? Equipment configuration, technical expertise. All of that will inform the results that are retrieved. And when you think about how people find information, right, they are looking for something. You can give people the manual, right, but they require study. That takes a long time to find questions. And you always hear RTFM, read the friggin' manual. TLDR, too long, didn't read. Or you can break it down. You can say, well, here's the manual, which is the way of giving them the 300-page document. You could say, look in chapter 4. You could say, here's the specific answer to your question from the manual. Or you could say, here's the specific answer from the manual and related information based on your exact product configuration and context. And this is what Trey was talking about. How do we understand the user's context? And this is through metadata. We understand it by understanding the descriptors of the customer and how those descriptors change throughout their journey, which is what I'm going to show again here in a moment. There's fast-moving metadata and slow-moving metadata, but the industry a person works in doesn't change every day. Intent, moment to moment, their work, their tasks do change, right, as we go through a journey. And this is an example of this, right? I reduced some of the clutter on this slide, but we call this a high-fidelity journey model because as you go through each of these steps, as you go through each of these journeys, what you're doing is you're seeing that this changes, that the metadata around the customer's data model changes as they go through that journey. Sanjay, I know this is a lot of what we have talked about. Do you want to add some color commentary?
Yeah, for those of you, particularly like if you're in e-commerce, if you think about gathering some of this signal data from a customer, maybe, for example, how did they get to the site? Where did they come from? Did they come from a campaign? And where did they land on the site is one of the first triggers, right? Of I'm aware, and are they landing on a category or a product page or a particular topic page where we might start that intent the inference, if we'll call it, right? And there we can automatically already potentially start creating some degree of personalization once they interact more with queries or by clicking other navigation links, for example, that might be other subcategories, or clicking on specific products. Those data entities, this is where the metadata comes in, also gets married to, for example, that signal. So it could be the product dimensions, the product attributes, the category and the aspects of that category. Is it an appliance department? Is it refrigerators? Is it stoves, right? Simple things like that get married to that user's sort of intent data at that moment, right? To start surfacing the most relevant. And again, as they go throughout this journey, that's that idea of kind of keeping that memory persistent. And that's the same thing we might bring also to the language models then, right? Is where even with a RAG use case of helping really restrict or filter what we want to bring back and have in that response. And I think that's key. And really can be applied throughout the journey, whether they are in one session or cross sessions or haven't visited in a while, right? Or coming from a partner. I mean, there's a lot of options, but this is really that exchange that I think is pretty important.
Yeah, and again, we have a more expanded or comprehensive version of this slide. I'm going to leave it in the deck so you guys can see it when you download your deck, or maybe we'll open it up at the end. But I wanted to at least show the idea of how the user's context changes and how their intent changes and how that can be identified with metadata. So, Trey, does this sync up with your intent idea?
Yep, it absolutely does. I would say that what a lot of people do is they figure, hey, I've got a public website, I don't have information on my users, or there's not enough interaction where I can really collect enough user signal data to build meaningful models. And what I would say is that I always tell people, from your very first interaction with somebody, you've got some information, right? You might have an IP address, so you can guess where they're located. You might have a single keyword. Well, that keyword is context. If somebody searches for the word driver, you may not know exactly what they mean, but if their next search is for printer, okay, well, now you can interpret driver within the additional context you have. If their next word is golf, okay, well, driver means a kind of club, right? And so every additional interaction you have with a user gives you additional information that you can use to understand them better, understand their context better, understand what they're looking for better, and to personalize their experience.
Great. So we do have this. This also talks about how to present the right content and product data in the context of this journey. But I think the main point here is to understand that user's digital body language changes. Here's another way to think about this: the fact that we need the context of the user and what they're doing, along with the content context. So if I were to say, how do I set up my modem? I would need to understand what modem it was. If I say, where's the installation guide? I need to know what model, and I need to get to that installation. If I have an error code, I need to find the error code for that model of modem. And so if I have a giant PDF, I need to break that up. I need to have it built into components. Now, companies are doing this for tech docs. It's called DITA. Oh, and we did have a question here. Okay, so you did answer this. Joku was asking if it's general public, how do you find the profile? You can find lookalike audiences based on their behaviors. And you can anticipate, just even if they're anonymous, you can look at the behaviors and predict something about those behaviors, as Trey was saying. But here's a piece of reference content that requires more context, right? And typically in tech docs, people are using component authoring so that they don't have to translate everything over again. You can have different models. It's easier to manage documentation in this way. So you break it up into these topics, and this topic modeling is ideal for retrieval with using a large language model. Fine. So if you're going to ask a human, I need to install a modem, they'll have a question. Well, what modem do you have? Right. So I have a particular product. I have the 2900 series, model 2960. Whoops. So here's the installation settings, and that's coming from this particular part of that 300-page document. I'm getting an error code of 50. Well, what does that mean? This error code is in this document, and it requires the following steps. But I needed to understand this document context in order to get to this specific piece of information. If I don't have this labeled in some way, it's going to be very difficult, especially in complex product manuals, to get to that right information. And so you start to see this as metadata that provides the context, right? It's the type of information, it's installation, product model, error code. So you can look at different content types. You can look at different attributes of those content types, and that will give you the context for you to retrieve exactly that information. Did you guys want to make any comments on this? Does this make sense to everyone?
One thing we see quite a bit is having the model for preemptively prompt the user, like the conversation starters, for example. And you think about, getting some of the signal data where instead of the customer having to kind of go through more of like that sort of this process, having the LLM sort of provide them a set of questions, right? Or those conversation starters on guiding them, right? So it's more like anticipatory guiding, or they don't even know how to, maybe what they're looking for or what information they need, right? But the system has learned what sort of dimensions are most important, right? So that's I think something that we see quite a bit and folks are really interested in using now.
Yeah, because again, what you're doing is you're building the use cases. You're understanding the role, and then you're saying, what does this role need to do? What are the typical tasks? And then you can begin by providing representative prompts to start that conversation. You could offer something up, or the LLM, the GPT could ask them a question. What kind of task are you performing today? Is it maintenance? Is it routine maintenance, preventive maintenance? Are you doing a repair? Okay, what kind of model vehicle is that? And what kind of, et cetera, can ask those questions, or the user can ask the question. But if we don't have the metadata at the component level, it's going to be very difficult to find exactly that precise information. Again, this may not be as big a problem if it's a policy or procedure, but it's when it's getting into technical details and when it's getting into very specific nuanced content, it is required to maintain that context. Go ahead. Yeah.
If you back up just 1 second, one of the great opportunities that generative AI offers us is, if you think about that 300-page manual that's on your desk and you have to read through that 300-page manual and pull out information and categorize it and tag it and find those pieces of relevant content that somebody might need, it's a little bit overwhelming to think about, gosh, how am I going to go through not just this manual, but 50 more behind it. An LLM can read that document and extract for you a lot of these question answer pairs, a lot of this categorized information. And that is a transformative opportunity that this new technology offers us, to be able to extract meaningful, useful, reusable content out of these large documents, where that had to have been a very manual process before. And if two people are given two documents, they're going to tag it differently. And so you're going to have some challenges just from that alone in terms of how you are able to find this content. That's just one of the many areas where these technologies can be very helpful.
Yeah, totally agree. And in fact, that's one of the things we're going to be doing in our workshop at KM World, is showing some of those techniques for how to process large amounts of content, how to componentize it, how to tag it, and then use it for retrieval. So all of this is very doable, and the tools allow for the scalability. It's combining the tools with the methodology, and that's the methodology that, a methodology we've built over a period of years that has to be applied to this, right? And many organizations don't necessarily know how to do that. Or they're not doing it because they don't understand how to make it most cost effective and maintainable. Let's see. So Sanjay, were you going to talk a little bit about stateless versus stateful or conversational?
Yeah, sure. I think many of the folks here in the audience have probably interacted, of course, with search and then of course probably with something like a ChatGPT now. And I think if you look at a couple of things, even the way to kind of compare the two, what would be stateless is really every time you provide a request like a search or query, it's basically starting fresh again, right? It doesn't use basically the results of your last interaction or your history of interactions to inform the next result, right? And this kind of even ties back to some of using that customer data and, for example, persisting like a customer's preferences or history or other what's going on in aggregate collaboratively with the audience. and informing that. So I think that's like a big one. And search has always traditionally been known as stateless unless you persist it and you give it some data for each request. That's the same thing with these LLMs. And so of course you've heard of threads probably, and when you think about chat and bringing these things together and creating a conversation loop, that's one of the pieces of being able to retain that continuing ongoing conversation. There's other techniques of what happens, when you leave, for example, and you come back, and how long does it stay? Like a lot of you might be using cookies, for example, to remember where the customer left last, like from a state machine kind of perspective and picking it up. Same thing. And that's where we get a little bit into like using even memory, for example, and feeding memory to these models. It could be that history that has been basically, it's gone stale, it's been too long. So we want to inject that back in. Part of it too, just one consideration is these context windows are getting bigger. You might have heard of tokens, and how many tokens can each model get, and they're increasing exponentially as we speak. But that again is how much history do you retain too, like, and how valuable and how valuable is more recent history versus the historical, like basically how stale does this data and history get? I think is something to think about. And this goes back to even the responses and how relevant was the past response to a current response. So a lot of nuances here, but that's kind of one way I'd try to explain my point of view on this.
Great. So that's very helpful in terms of thinking about how we're designing those systems. Are they going to remember the past conversation? Are they going to remember earlier parts of the conversation? And that's maintaining context as well. There's a lot of text on this slide, so I think I'm just going to talk to it at a very high level. I think one of the most important pieces, obviously, it's the upper left corner and the lower right corner. It is the data quality and data hygiene, and it is the knowledge and semantic architecture. So how are you building those knowledge architectures? Are you building those knowledge models? Do you have capabilities in information architecture and knowledge lifecycle, right? Because that's very, very important. And there's an increasing emphasis on this now when organizations are trying to get this stuff to work correctly. Any other things that stand out for you guys? Trey, Sanjay, Patrick, what are your thoughts on this big texty screen?
I'll say on my end, there's a lot of obviously important things you have to think about and challenges here. One that I just want to sort of emphasize, because I see a lot of people doing this wrong, and it's very dangerous to do it wrong, is a lot of people think I've got my large language models and I've got my data, and the models aren't fine-tuned for my data. So obviously the thing I need to do is give them my data and fine-tune them to my data. And while that sounds appealing, the problem is that your data isn't necessarily public data, right? It's, some of your documents are internal only. Certain employees maybe can only access certain documents. Some of it's highly sensitive. And so if you train the models on that data, when someone asks the model later a question, the model may leak your private data in a way that could be a security nightmare, or just ultimately, you just can't do that. And so one kind of really important distinction between the generative models and the retrieval side of this with the search engine and vector database is you need to make sure that data that is not intended for anybody to be able to access stays in your search engine. And whenever you need access to that data, for example, if I were to ask within my company's LLM, hey, what is the revenue forecast for the upcoming quarter? Maybe if I'm in finance, that's okay. But if I'm in another department, it's not. And so when the generative model goes to actually query the search engine to get the R part of retrieval, to get the data, it needs to have the understanding of the user, what they have access to, and only access documents the user is actually allowed to see. And so I think that distinction from a security architecture standpoint is really important. It's this handling sensitive data piece that we have up here at the top right of this slide. But I see a lot of people make naive assumptions that the model should just get all of your data, and that's really not safe. So I just wanted to emphasize that part.
That's a great point. We have to have security trimming in there. There was a question about incognito mode. And again, when we're looking at RAG, we're really usually thinking about this from an authenticated perspective. So if you're not authenticated, you're not going to get to the company information. So that's kind of looking at this from an internal perspective. So you need to have some credentials to get to that data. As Trey is saying, you also have to security trim the data. Okay, any other comments on this particular slide?
I might add one just that really kind of gets to the information architecture aspect of, I'll pick on the data silos, and integration is something we see quite a bit. And it even ties to like noise and semantic architecture. If you think about bringing multiple sources together, I'll pick on like one type of metadata field, which might be called the category, in one source, but it might be called a family in another source, but then called a group in another source, right? That's like a field or a metadata field that we're again, coordinating that, like the meaning of that field and what its purpose is across those, is one of those sort of challenges that we're like an information architecture, and having kind of that dictionary, right, or shared dictionary, I think is something important to bring in to get around some of that challenge, because that comes up a lot, especially back to federated search, right? Like
Yes.
the retrieving side. So
Yeah, that's a great point. When we just did that federated search project demonstration, we found that the labels and the categories and the metadata across these different systems were very inconsistent. And so you had to map them together. But we also had variations in terminology, in the vocabularies, and so on. So it is a big tangled mess sometimes to straighten that out, especially when you're looking at multiple data sources and trying to bring them all together. By the way, there is a Q&A tab. I think it's under more. Usually it was right up in the but I think they changed things around to make them much less convenient. So if you have any questions, you can put them in the chat as we're seeing, or you can put in the QA section. So how do you get started? Well, my belief is you start with use cases. What are you trying to accomplish? Who is trying to accomplish those things? And we have to know what good is. If you don't have use cases, how do you know you're successful? Use cases say they're unambiguous and they are clear in outcome, and they can be tested and validated. So can they do it or not? Can they perform this action or can they not perform the action? So a bad use case would be, use RAG. A good use case would be retrieve service information for a particular model of vehicle, for a particular technician solving X kind of problem, right? It's real specificity about what actual information people need, and then how we can get to that. So you build libraries of use cases whenever you're doing these things, and then you can test them. You can also use that for baseline metrics, right? What is the current state? What does it take to accomplish this task or find this information or do this onboarding or the time to value? So all of those things, the use cases should correlate with things that are also measurable in some way. We have to understand the data sources, right? We have to identify their completeness, their quality. We have to understand, if we are missing the information, and then again, this is to satisfy the use cases. And then we have to make sure that we have the right content and knowledge architecture, because we can have the data, but it may not be correctly tagged and labeled for retrieval. We may have versions that are out of date. We may have very fine distinctions and meanings around particular documents, or slight differences in documents that need to be called out in some way with metadata and with the content architecture. So this is the way to understand the isness and aboutness. What is this thing? It's a procedure. What is it about? It's about changing this particular part in this vehicle. And governance. Governance is going to be important. You have to get this stuff right, and you have to keep it right. You have to make sure that you're keeping these things up to date. There should be a governance process you can plug into, but you will need to understand content and knowledge life cycles. And of course, piloting it in a particular domain to gain that experience and understand that feedback and to see how well it's performing, test it in the wild. But you're testing it with a controlled group, and you're also testing against the use cases. And you're going to get variations in the responses. So sometimes you need to use an LLM to determine if answers are equivalent. Anything you want to add to these steps, Patrick, Sanjay, Trey?
I would just say, from folks who haven't tested something like a RAG out yet, or trying to be very cautious about it, you may, especially in the e-commerce, we maybe don't see it being deployed on the customer facing side, but we may
Right.
see you trying to, there's tons of use cases on the back end side. I mean, one
Yeah.
common one would be, for example, in data enrichment or product enrichment before it even gets into like an index and all that. And
Yeah.
actually, the LLMs are extremely powerful at doing all sorts of things like synthesizing data, as we all know. That's a generative piece, right? Like generating descriptions or contextual
Mhm.
descriptions or generating additional fields or telling you what fields you might need. Just to throw that out there, that's a lower risk type
Yeah.
of path to pilot these out as
Yeah.
well.
Absolutely, internally facing, but also data remediation. We've developed some algorithms that are very, very good at combining different data sources and filling in missing data. It uses an agent approach, and it cycles through large amounts of data, uses the current state of the data as a prompt, and then the response becomes the enriched data. And we can demonstrate that for anyone who is interested in it. It's a very powerful technique, and it really brings data quality to a new level. And as we're saying this, the tools have advanced to such a degree that you can accomplish this data cleansing and this data curation and this modeling in ways that are much, much different than they have been in the past. So there's a lot of advances in this area, and we'll be happy to talk about that. In my perspective, the future of information retrieval is really about information architecture, and LLMs are going to be more powerful, but it's going to be more important that we have that IA to make sure we're getting the right information. And intelligent componentization is really the best way to make sure that your LLMs are getting the data that they can respond to questions. You're building question answer pairs, and you're essentially extracting the knowledge and data from documents. You're curating it, you're tagging it, you're helping the LLM understand the context of the data and provide a more accurate result, instead of thinking that, this, if we just ingest it and let it do its own thing, it's going to figure it out. No, you have to be very intentional about this, and you can get great results. And of course, we have to think about data privacy. We need to think about guidelines. We need to make sure that we can improve this performance and at the same time safeguard your IP. Any other comments on this slide?
Yeah, Seth, I was just going to say, I'm more on the technical side and implementing and kind of trying, what's on the frontier. And two pieces of this. One, oftentimes people get scared by, this big buzzword of RAG and what do I do? And like, I need to like basically boil the ocean. I have to solve every problem all at once. So no, you don't. I think starting off with a specific use case, maybe it's just summarizing documents, maybe summarizing, single search results or single sets of search results. It's a good way to get started and see the power and the value, and then figure out how you can extend that into all the rest of your information architecture and the rest of your organization. So one, don't be afraid, because it is very powerful to get started. But two, where this ultimately heads once you get started and actually start adding value and more value is, these days we're talking a lot more about agents and about having, multi-step processes where you might have a query and there's software that's running that uses an LLM to find some information, processes that, maybe goes and finds more information, and it's almost like doing research. And that's a more advanced version of this, but having the right information architecture in place so that those things can be added in and you don't just have a giant mess is really, really important. So whether you do it on day one or do it, a little bit into the process, ultimately the information architecture is critical to building these things out.
Absolutely. And I do want to mention, we do have a knowledge management and AI readiness assessment. It helps get everybody on the same page in terms of the capabilities and limitations. You look at your use cases, the high value use cases for generative AI, look at success metrics and factors, and it looks at the critical areas of business and comes out with a generative AI proof of concept plan, or proof of value, really. That's the term we use preferentially. But the idea is to say, how can you get this to be practical? And that can be done in as little as a few weeks. And if you schedule an assessment before November 15th, just schedule a conversation, not do it. We'll give you 20% off of the assessment. And you can just write a note to carolyn.southwicketearly.com. We'll also have this in the follow-up email, so anybody who's attended the webinar can get that. With that, we are right at the top of the hour. Any final comments from our panelists?
I want to echo what Trey said. This is rocket science, but it doesn't need to be that scary. It actually isn't as hard as it can sometimes seem. And there's not it's approachable, it's usable, it's valuable, and I think you'll find in your business that it accelerates your ability to move forward, especially not just in your business, but against your competition. So it's worth digging into, and I encourage you to do that.
This can be a tremendous competitive advantage for organizations, and it's very practical. And again, we can really get you along that path. I want to thank our guests today. Thank you, Trey. Thank you, Sanjay. Thank you, Patrick, Carolyn, for doing stuff behind the scenes, and for everybody who dialed in and enjoyed this today. Thanks very much, and we'll see you hopefully soon. And reach out to schedule that discussion around the assessment. We can talk about it and get you guys started. Thanks very much, everyone.